Thanks for joining me again today, Megan.
No worries, thanks, Leanne.
Today our topic's a bit of a, it's a very topical topic. Lots of parents have questions about COVID vaccinations in children in Australia, so we can't pretend to have all the answers. I certainly can't as a psychologist, but that's why I've got you here today. But we can try our best to give what we think is the best advice based on evidence-based information that's, the most current that's available to us at the time.
That's right.
It's just such a new area, isn't it?
It is, and I have to say that, I'm not pretending to have all the answers either. I've done a bit of reading around it and a few searches because parents have been asking me. And so, today we're going to have a chat about some of the information that's out there, and we're going to answer the most common questions that we've been getting in the best way that we can.
Yeah, no, I think that's great because there is a lot of different information about there, and there's a lot of people have, fears, or they might hear different things, and so it's hard to wade through it. And I'm so very glad that I've got you here to help us with that today.
I really hope I can help.
Yes, I'm sure it will. So we've got some questions that are common ones that we have from parents. And the first one is, I guess, having that they've heard that vaccination could soon be expanded to include kids who are 5 to 11 before Christmas this year. Yep. So is, first of all, is that true? And then what advice would you give? Should parents get their kids vaccinated?
Okay, so the answer to this is a little bit tricky, and I had to look this up. But this was, so Christmas, it's November now.
Yeah.
Christmas is really, really close. So previously it was anticipated that they would manage to roll out the vaccinations for 5 to 11-year-olds before Christmas, but in the first week of November, which is now a couple of weeks ago, the Federal Health Minister, Greg Hunt, indicated that it was unlikely that was going to happen because at that stage, Pfizer, whose vaccination we would use in that age group, had only submitted the very first part of their data for the younger cohort to the Therapeutic Goods Administration. And it was expected that there would be more data to follow in the ensuing weeks. So obviously Australia is a bit behind the US in terms of our safety data and our data on vaccination rollout. But in late October, the US Centers for Disease Control, or the CDC, which a lot of people have probably heard about recently, they became the first health regulator to recommend emergency use of the Pfizer vaccination among 5 to 11-year-olds after being advised by the FDA, or the Food and Drug Administration. Despite that, in Australia, one of our experts from the Murdoch Children's Research Institute, Associate Professor Margie Danchin, was quoted as saying that regulatory approval in Australia for the Pfizer vaccination in 5 to 11-year-olds is unlikely to be given at least until early 2022.
Okay. Yeah, so that gives us the answer about when it's likely to be available. Can I just ask a question that they were talking about emergency use? What does that mean?
I think it's around if children have had exposures. I don't know exactly, but I assume that it's around exposures, or there is sudden an outbreak in a particular area, and children are considered to be high risk.
Sure.
So,
yeah, that's what I was thinking as well, that for whatever reason maybe there's a higher risk at that time. Yeah. Okay. So you mentioned the Pfizer vaccination. Which vaccination should parents consider for their children?
Okay, so in Australia, everyone would know about this. There was that big hoo-ha a while ago where originally we had supply of the AstraZeneca vaccination and Pfizer was a little bit harder to get.
Right.
And then the recommendation came from our health minister that we should reserve the AstraZeneca vaccination for older populations because of the risk of blood clots in younger people.
Yeah.
So I think it's unlikely that the 5 to 10-year-old age group or young people are going to have a choice.
Right.
With respect to which vaccination they get. It's going to be the Pfizer vaccination. Okay. And at this stage, Pfizer is the only company that's actually applied for approval for use in the younger cohort in Australia.
Right.
I know that in the States, there has been a lower dose Pfizer vaccination compared to what adults have been inoculated with or have been given. Probably inoculated is not quite the right word because it's an mRNA vaccine, but it's a lower dose in children than what we have been using in adults.
Okay.
And the doses are given 3 weeks apart, and each dose for children is about a third what we would give an adult.
Okay.
Or a child aged 12 years and over.
Right.
So the reason why they're giving that lower dose is because the company that's manufacturing it, Pfizer, has said that the rare risk of developing heart complications or the myocarditis or that heart muscle inflammation would be reduced on a lower dose in children.
Okay. Yeah, that was going to be... So, but then is that lower dose less effective?
So that's a huge question that a lot of parents have had.
Okay.
The answer to that is that for primary school age kids, that third of the dose that has been trialled in children has shown that the antibody levels that are produced in children in response to that lower dose are just as good and just as strong as they are in adults and teenagers that get the higher dose.
Okay.
So having said that, the information that I have read has been from the manufacturer. Okay. So it has been released by Pfizer, and I can't say that I have looked at that information really closely and been able to critically evaluate what that means in terms of, is that study valid, is that information valid, but that's what the process of, Pfizer turning over that information to the FDA and then FDA advising the CDC on what the best course of action would be as a result of that data, and that's why that process happens. And I guess I just trust the experts and people who have devoted their lives to working on this sort of thing to give us the right recommendation based on that large population data.
Yeah, sure.
I guess the other thing that I wanted to say was that if we talked about the effectiveness of the lower dose, but it's really important to note that lower dose is also proved to be safe in the younger cohort as well, and the side effect profile was found to be similar to the higher dose. So common side effects occurring commonly, so things like sore arms, fever, muscle aches and pains, but yeah, essentially it's safe to use in that younger age group.
Okay. You mentioned a little bit before something about inoculation and how maybe that's not the right word because it's the mRNA vaccination. So what is an mRNA vaccine and how does it work?
This is a really, really huge question, and I've actually had quite a few families ask me that.
Yeah.
Now, molecular biology was a subject that I did at uni, and it was a big subject and it was really complex, but trying to explain this is actually, in a simple way, is quite hard to do, but we're going to give it a crack anyway.
Yeah.
So don't mind me as I refer to my notes because I've tried to explain each step simply.
I think it's actually important too, because then we know that, it's important to make sure that you're not skipping the steps or forgetting. So
yes, that's right.
Yeah, I think It's a great thing to refer to.
Thank you. Okay, so the coronavirus, just like many other viruses, uses a protein on its surface to attach to a human cell and then to enter the human cell. Okay. Our body, our immune systems can produce little proteins called antibodies, which fit into those surface proteins of the virus, and they can block the virus from being able to attach to the human cell and to enter it.
Yeah.
So mRNA vaccines teach our body's immune systems how to make those antibodies so
Okay.
that we can block the virus from entering our cells.
Right.
Okay, so that's a really super simple
Yeah.
explanation. But let's go into it a little bit further. So mRNA stands for messenger ribonucleic acid. We don't really need to worry about that. It's a bit long term.
good.
But basically means that it's genetic material that instructs our cells to make particular proteins. Okay, and depending on the type of mRNA and the sequence in the mRNA will dictate what kind of protein it teaches the body
Yeah.
how to make. So the mRNA that's in the vaccine is wrapped in a layer of fat particles that protect the mRNA, but also help it to be taken up into our immune system,
Yeah.
into specific cells in our immune system called dendritic cells. Okay, and dendritic cells are like funny looking cells that have sort of like little arms and lots of little protrusions in them. I used to love drawing them in my immunology book when I was at uni, and colouring them in nice colours. I don't know what colour they actually are. So once the mRNA is inside the cell, it doesn't actually enter the cell's nucleus. So the cell's nucleus is where our genetic material sits.
Sure.
So a lot of people have misconceptions about that.
Yeah.
But the mRNA does not go into the nucleus, and it does not interact with the person's DNA at all.
Okay.
All right, but what it does do is it remains in the cytoplasm, which is the jelly-like substance that fills the cell, and with the other mRNA molecules waiting to be read so that the cell can produce particular proteins and enzymes that the body needs.
Right.
So there are little proteins in the cytoplasm called ribosomes. Okay, and these ribosomes, their job is to read the mRNA particle and to translate it into a protein.
Okay.
Right? So it reads the mRNA particle that comes out of the virus vaccine, and pieces of the virus surface protein, so that, that one that we were talking about is on the surface of the virus that helps it to bind.
Yeah.
So those little surface proteins are actually produced, and then the dendritic makes like a Christmas tree and it presents it on the outside of its surface.
Right.
And what happens is it's floating around, so the dendritic cell migrates then to the immune system tissues. So you might have heard of these before, but lymph nodes. Sometimes you get lymph nodes up in your neck when you've got a sore throat and stuff.
Yeah.
So your lymph nodes are your immune system tissue, and the dendritic cells migrate to the lymph nodes, and it presents that viral protein like a trophy that it's just made to all of the white cells in the body that help us to formulate our immune response. So there are a heap of different types of white cell, but the particular ones of interest in this particular case are the lymphocytes. So there are T lymphocytes and B lymphocytes. The helper T lymphocytes are a type of white cell that train the B lymphocytes to make the antibodies.
Okay.
So B lymphocytes make the antibodies that help us to protect ourselves. Okay, so the T lymphocytes train the B lymphocytes to produce the antibodies that perfectly fit into that virus protein to block it from entering our cells and from binding to the surface of our cells.
Right.
There are another type of T cell called a cytotoxic T cell, which I think is a really dramatic name.
It does sound dramatic.
But essentially what it means is that these particular cells are killer cells, and so when they learn how to recognise this viral surface protein, they can identify and they can kill cells in the body that are infected with the virus. So essentially what it means is that our body is better able to more rapidly able to recognise infected cells and, block that virus. So we get vaccinated with the mRNA vaccination, and then our body learns from that vaccination, and when the borders all open and the virus is running rampant through the community, our bodies are ready.
Right.
And our bodies will recognise the virus, they'll block the virus, they'll neutralise it, and they'll destroy the virus in any of the cells that it's infected, often sometimes even before we realise we're sick.
Okay. And so that is different to the way that vaccines have worked in the past, is that right?
That's correct. So, I guess the most one of the more common types of other vaccinations are when you have a part of the virus that's been all crushed up. So it's inactivated, but you've got pieces and shards of the virus,
actual virus,
and you inoculate someone with that. And it's similar in that when those particles of the virus are presented to your immune system, the virus can't infect you because it's deactivated and in pieces.
Right.
But your body, those T lymphocytes, those B lymphocytes still recognise those virus particles as foreign, just like they would on a dendritic cell surface, and they produce antibodies in response to that.
Right, yeah.
Okay, so it's a slightly different mechanism, but just as effective.
Okay. Yeah. I think that's maybe, it contributes to why this is such a new or overwhelming topic for lots of people, is because all of this COVID stuff is happening really quickly and things are changing, but also then we're talking about a vaccine that works in a really different way to what we're used to. Well, I mean, to the lay person.
Yes, for sure.
It's different, so we just, it's a new thing for us to get used to and learn about.
Even though apparently, well, from my reading, the mRNA vaccination technology has been around for 20 years. But I guess our hand has been forced in some respects that this pandemic has caused us to move forward with that technology much more quickly than would otherwise if COVID never existed.
Yeah, I'm imagining that the amount of people getting vaccinated for this new thing is way beyond what would normally have been experienced.
Yeah, absolutely.
Yeah. And so then I've heard that children are at lower risk of severe illness or death than older people. And so on the basis of that, how does that help weigh up the risk? Is it safer to not have children vaccinated?
Okay, so this is a really difficult question to answer because, even people in the media, our government officials, our health officials have been saying different things. So I'm going to try to present both sides of the argument. So whilst it is true that kids tend to get a less severe illness and are less likely to die from COVID-19, more recent variants like the Delta variant of the COVID-19 virus has proved more infectious in the younger population than previous iterations of the coronavirus.
Right.
So according to the American Academy of Pediatrics website, and this is where I'm sort of referring to my numbers because I can't remember them off the top of my head, as at the 9th of November, so I think it was last week when I was looking all of this up, 6.3 million children have been infected with COVID-19 since the pandemic started. 70,000 children have been hospitalised that 6.3 million.
Yeah.
897 children under 18 have died from COVID-19, and it was the 9th leading cause of death amongst children aged 5 to 11.
Right.
So when you look at that data and compare COVID-19 to other diseases that we routinely protect children against, like measles, hepatitis A, meningococcus, rubella, chickenpox, those sorts of things. Many, if not most of these diseases killed fewer children per year than COVID-19 has.
Okay.
But we protect our children against those. And I think the longer that we wait, so a lot of parents are like, should I just wait and just see, what other information comes out?
Yeah.
But the longer that we wait, the longer children are walking around unprotected, the more likely it is that infections will be spread to younger children who are not yet eligible for the vaccination. It's more likely that more virulent forms of COVID-19 will evolve. And we already know that the Delta variant is more infectious in younger people, and it's changed from the original virus that was originally the problem.
Yeah.
And the other thing in a practical sense, the longer that you wait to get your child vaccinated, the longer your child will have to wait for a booster. And that could prove very risky in a situation if you have a really nasty variant that emerges. and then a new round of vaccination is needed if your kid's only just been vaccinated and they have to wait a minimum amount of time before they
have their
get the booster,
yeah.
then your child's walking around at risk of that new nastier variant. So I guess there are quite a few reasons why I think it's important to not wait to have that done, particularly when the government's talking about opening borders and all those sorts of things.
Yeah, sure. That helps put it in perspective, I think, and think about it from that point of view. Mm-hmm. I guess we've talked a bit about, the risk about kids getting COVID as well, but some questions here are from families who are worried about myocarditis and pericarditis as a side effect from the Pfizer vaccination in their children.
Yeah.
Wonder if you could tell us about that. First of all, probably what those things are for the non-medical people.
Absolutely. So this is a really common concern. So we talked about previously heart complications that can occur following a vaccination or even from the COVID virus itself. So myocarditis is an inflammation of the heart muscle, and the condition that results can range from mild to extremely serious to fatal. Pericarditis is the inflammation of the pericardium, or the sac that the heart sits in.
Okay.
And that can also be very serious, okay, or mild to very serious. So again, I'm going to have to refer to my numbers for this. But I will prelude this with, I looked at quite a few different studies, and depending on which study you look at, they give you different statistics, so slightly different statistics, but on the whole, the studies that I looked at were all in agreement. Okay, so the risk of myocarditis in individuals with COVID-19 infection, so people who actually get the virus, is 6 to 34 times higher compared to those who receive the mRNA vaccination.
Okay.
So that is COVID-19, the virus, causes myocarditis both much more frequently and much more severely than the vaccine.
Okay.
In one study, and I'm happy to provide the reference if anyone wants it as well, the study size was 718,000 patients that had COVID-19. 5% of them developed new onset myocarditis and 1.5% of new onset pericarditis. So 5% of patients that get myocarditis, that's 5 in 100 or 1 in 20 people. That's a lot.
That's a lot, yeah.
That's a lot of people for a condition that potentially could be fatal. In a separate study, reported, this is a 2021 study, reported that in a population of over 2 million individuals receiving COVID-19 vaccination, myocarditis occurred primarily in younger male individuals a few days after the second vaccination at an incidence of 4.8 cases per million.
Okay.
That is 0.000048%.
Yeah, so
as opposed to
compared to
5%.
Yeah.
So it's just so much less common, and you're going to be so much worse off if you're not vaccinated and you get COVID, and then you end up with myocarditis.
Right.
Okay, it's going to be more severe, and it's going to be much more frequent. And I guess it's so hard at the moment. There's so much controversy and so many different opinions about vaccination. I think when you talk to health professionals who are trying to give you the information to make the right decision for yourselves, all we can do is base it on the evidence.
Yeah.
You need to trust that your health professional knows how to analyse the data that's out there. We went to university for a long time, and even when I did my pharmacy degree, there was a subject called evidence-based medicine, and I did that for 4 years before I did my medical degree, and then had to do evidence-based medicine again throughout my medical degree. And it's not easy to tease out the validity of the data in all of these studies, and there's a lot of stuff out there that has nothing to back it up, and it's very sensationalized, and they're YouTube videos, and people saying all sorts of things, and as a layperson it is really difficult to discern which of that information is real,
yes,
and which is not. I think the important thing to know when you're talking to your paediatrician about vaccination, no one is trying to convince you that these vaccinations have no side effects. Okay, I certainly don't. In fact, side effects like fever, muscle aches, sweats, fatigue, they're super common, and particularly after the second vaccination, up to 60% of people will get side effects like that after the second vaccination. The serious side effects, though, like the ones that'll kill you, are super duper rare. And as demonstrated by some of those studies, you're more likely to die so much more likely to die from the actual virus than you are from the vaccination. And what we're trying to do is we're trying to make sure that people are aware in weighing up benefits and risks, that when we open the borders, and in Victoria, I think a few days ago, I was looking at the numbers, we're still getting 800 to 900 new cases in Victoria a day. When we open the borders, this virus is so virulent and so contagious that it is inevitable that everyone's going to be exposed at some stage and probably catch it. And I guess the suffering and the death that is caused by the actual COVID-19 virus is so much higher than those side effects and suffering caused by the vaccination, that in our minds as health professionals, or at least in my mind, I know I can't speak for all health professionals, in my mind it's actually a no-brainer. When my children can get vaccinated, they will be getting vaccinated.
Right. I think it's I'm so glad that we got to have this conversation today, because it is really difficult, I think, for a few reasons for families. One is that we've never really had this kind of viral outbreak in our country anyway.
Not in our lifetimes, hey?
No,
so.
But I mean where we've had to move quickly on these things, and so most of the time, we're not referring to emerging research, we're referring to past research and that kind of thing. So I think it's, if people are being, weighing things up and interpreting the data carefully, I think that's a really great thing, because that's all you can do.
Yeah.
But the other thing too is that we've never had this from my point of view, in America it's common for medications and stuff to be marketed on TV and that kind of thing. We don't have that in Australia, but it's become into the mainstream about this COVID vaccination, and so we've had a lot more exposure and politicians commenting on it, or other people too, than we usually would. So I think it's there's so much differing information out there, so it's really good to talk with somebody who's double qualified, really, if you think about the pharmacy and the medical degree, to really weigh it through.
I found it hard reading about all of the information that's out there, and that's with the background knowledge, so I can only imagine how difficult it must be for parents to wade through that volume of information to know what to trust. And as I said, not everyone will necessarily agree with me and my interpretation of that data, but all we can do as a group of health professionals is try to advise our patients and our cohort as best we can based on the evidence that we've got.
Yeah, absolutely. Thanks so much for spending the time and talking that through with us today. I think it's going to be really beneficial for our families.
No worries. Thanks, Leanne.